Just adjust the shot here for a second. Oops, go the other way. Okay, so starting off, one way in analysis of variance. A study was undertaken to investigate the water holding capacity of the soil in 3 different areas of woodland. In each area, a number of soil samples was collected randomly, and sent to the same laboratory for analysis. The following table gives the water holding capacity in milliliters per gram of the soil samples collected in each areas. So we have 3 areas and therefore 3 groups of samples. So woodland A, woodland B, and woodland C. Here we have 10 observations from woodland A, 8 observations from woodland B, 6 observations from woodland C. Just before we even get started, alright, carry out a suitable analysis. So that's one way analysis of variance. Stating the assumptions. Quite an important thing to do, state the assumptions you make. I'm just going to, for the sake of brevity, skip them, but it's normality, equal variance, independent sampling, stuff like that. So it would be take a bit of time to actually state them properly. And anyway, going on, explaining how what you conclude. I tell you what, in this video we'll just actually get the ANOVA table up and running, and you can interpret it from there. So we're just going to concentrate on getting the calculations done. So just a couple of quick remarks actually. The overall mean, we have 24 observations there. Okay. And the actually I'll just write that down. N is equal to 24. Number of levels is equal to 3. Okay, so that's the different number of groups, so that's K is equal to 3. Also the mean, the overall mean is, let's just check that now with my calculator, is 57.46. The mean of group A is 66.4. The mean of group B is 39.125. The mean of group C is 67. It's actually, this is the key thing actually, these group means. Essentially what we want to do is there a significant difference between the woodland areas in terms of water holding capacity based on these means, because B is very conspicuously different from the rest. But is it different enough that we can say it's a significant result, or can we just put it down to a bit of the null hypothesis is that it's just due to random error, random sampling error. So that's what the point of this one-way ANOVA procedure is, just to sort of say, is one of the woodland areas significantly different from the rest in terms of values and in terms of measurements. So that's the gist of it. So moving on, let's get into the business of let's scroll down here a bit. What we have here is the total sum of squares. Okay, these are the sums of squares identities. The within group sums of squares, this is essentially for the error terms. Okay, W is for within. And between groups sum of squares is essentially for the main effect. Okay. Now, so what we're going to do actually in each of these 3 cases is that we're going to use some of our results already. For example, we have the mean of groups A, B, and C there, and we're going to use that in here. But you notice that quite a lot is to do with the overall mean. Our two major calculations are dependent on the overall mean. Also, just notice here that we have the size for each group. So we have one group that's 10, one group that's 8, one group that's 6. Depends on what group it is. So let's get cracking at this. So we're going to do all of these, even though correctly. In this video, I'm actually going to do all of them. SST should equal SSW plus SSB. That's one of the key properties of ANOVA, that these sums of squares actually add up to each other. But for the sake of just completion, I'm going to do all 3 anyway. Okay. So let's do the first one here. So in this first example, what we'll do is I'm going to scroll down here again. What we have to do here is compute. This is a bit of a long-winded exercise. So for each group, essentially for each observation within each group, what we have to do is subtract the overall mean and add them all up. So this is a lot of calculator work. 72 minus 57.46 squared plus 51 minus 57.46 squared plus 38 minus 57.46 squared, and so on. I think you get the idea. And when you do it for all 24 observations, okay, the whole lot, hopefully in a real exam that you'll have a sort of partially completed table, so you might be able to skip some of this stuff, but for the sake of this exercise we're just going to go at it from the point of view as if we're doing it for real. Just a sort of quick remark, where is this 57.46? Bit of revision, that is the grand mean of all 24 observations. Okay, now when you work that out, what do you get? I'll actually just write it down because I have it written down and I just get my notes up and running. The overall mean is the sums of squares total is 7935 or actually we just rounded up to 96. Okay, 7935.96. That is SS total. Okay, so that's one of the jobs done. It actually it's very long, but actually it takes a while to do. It's actually a very straightforward exercise. Apart from that, the next thing we are going to do, that's just a bit of blank page for the sake of space. What we're going to do now is look at the within groups sums of squares. Okay, so this is a slightly different. I'll just draw your attention to what we're doing here is, rather than the overall mean, what we're going to do is subtract from the mean of that group. Now let's just recall what our observations were here. The mean of group A was 66.4. Let's just write them on the side. 66.4, 39.125, and 67. So what we're doing here is 72 minus its group mean, 66.4, square that, plus 51 minus 66.4 squared, and so on for the rest of that row. Then we go down to the next row, 35 minus 39.125 squared, because that's the mean of the group mean for woodland B, plus 33 minus 39.125 squared, and so on. And then at the end we'll do the last row here, 54 minus that the mean for group woodland C, which is 67 squared, plus 62 minus 67 squared, and so on till you have all 24 observations done, where you subtract the mean of that group, square it, and add everything all up together. Now that one is, let me check now, works out to be, in my calculation, that works out to be 3901.275, or we'll just leave it as 27. Okay, so that is SSW, or the error. Okay, and that is 3901.27. Well, you put in the 5 there if you want. We'll try and keep it the decimal places pretty consistent. Now the next one, it's a blank page, the between group sums of squares. So what we're going to do in this instance is subtract the group from the group mean. We are going to subtract the overall mean, square it, and then we're going to multiply that by the size of each group. So this is actually a rather quick exercise. This is equal to 10 times what's the mean of group 1? 66.4 minus 57.46 squared, plus 8 times 39.125 minus 57.46 squared, plus 6 times 67 minus 57.46 squared. And I work that out to be, what do I work that out to be? Sorry, just check back. 4034.6968. Don't worry too much about the decimal places, because you can probably, once you're trying this out in your calculator, you know that the calculations can get really lots of decimal places. So that is the between group sums of squares. Okay, and that's the main effect we're going to be looking at. So now we're already pieced this all together. That's that done. Sorry, just loads of space left over here. And let's draw our table now. So I have a sort of facsimile table here ready. So the woodland, just going to write it out here. The woodland is the source. That's just a little, up there is, well, a little cue for me to read off. It's supposed to be a straight line, not very straight. Degrees of freedom, sums of squares, mean squared, and then f. As far when we get to the f value, I'm going to finish up. So residuals, which is SSW, and then total down here. Okay, so what do we got? The degrees of freedom. Now, levels. There were 3 levels of degrees of freedom. So 3 minus 1, or k minus 1, where k is the number of levels, that is equal to 2. There is 23 observations altogether. 24 observations altogether, so I'm getting ahead of myself. So it's n minus 1, and that is equal to 23. And the difference, therefore, between 2 and 23 is 21. That's how we know what to put in there for residuals. The sum of squares is something we've worked out there, 4034.68, 3901.27, and finally, what did we get at the end? We got 7906. 7906. Yeah, well, close enough. 7905.98. Okay. Now, those 3 calculations are what we've worked out from first principles. Now, you actually could have found that 4034.68 plus 3901.27 should give you very close to 7905.98. Now, obviously, the second decimal places, yeah, just can account for some rounding error, but more or less they should add up. And again, so that means we didn't actually need to calculate all 3. We only needed really to calculate 2 of them, and then we could figure out the third one from that. But best to get practice at this. Now, mean squared. This is where we are into new territory. The mean squared. Actually, I'm just going to bring this down a bit. The mean squared is the sum of squared divided by degrees of freedom. Okay, so 4034.68, divide that by 2, we get 201.34. Divide 3901.27 by 21, and we get 185.77. Okay, we don't compute mean square for a total. Okay, that's gone. So just leave that blank. It's supposed to be left blank. Now we're going to compute our F statistic, and the F statistic is the mean squared for each factor over the mean squared for regression, or for residuals. Okay, so for the main effect, actually, sorry, it's the word I'm looking for. The mean squared for the main effect, or well, all of the effects. So it's just a general rule. So 201.34 divided by 185.77, that gives us 10.86. Now, this is our test statistic. Okay, and we base the our conclusion on this test on that test statistic, but we're also conscious of the fact that when we use that test statistic, the degrees of freedom are over here, and they are 2 and 21. Okay, so that's your table made up. We got all the sums of squares from first principles. Interpreting is for another video, and also talking about the assumptions as well. That's for another video. All right, we'll leave it there.